My dear friends, hope everybody is doing well. So today we are starting my lecture series for engineering mathematics focused mainly on GATE 2021. So you have November with you. So October is ending now. November, December, January. 3 months you have, and I will be giving you engineering mathematics class, and maximum I will try to finish it this by November. I will try to finish mathematics, all the complete topics which I have mentioned in my previous video. So today we are starting with probability distribution and statistics. Okay. So as I always tell you, be consistent at every situation. That means watch all the videos, make notes, do the problems. So in between, I'm giving you a lot of problems. So try to pause the video, try the problems by yourself, and then check the answers. Okay. So as he told, engineering mathematics is for 13 marks, and this is probability. So first topic is probability, and it consists around maximum you will get 4 marks out of 13. 3 to 4 marks definitely will come from probability itself. So to start with the basics, we have, so what do you mean by probability? So from your school itself, school mathematics, then now in the engineering mathematics, everywhere you're studying probability, right? You see a probability, number of favorable outcomes by total number of outcomes. All these things you have been hearing from your lower classes, right? So probability is actually based on some random experiment. So today's session will be based completely on probability basics. But from this basics, you will definitely get questions. 1 mark question, 2 marks question, multiple select question, MSQ, multiple select questions, because there will be more than one correct answer and you will be confused. That question also you will have. Okay. So regarding a random experiment, so random experiment is it's an experiment or process for which the outcomes cannot be predicted with certainty. So for such random experiments, we don't have the outcome with certainty, so we consider the probability of occurrence, right? So you have a multiple choice question, you have 4 answers, so out of that 1 answer will be correct and other 3 will be wrong. So the probability of getting a correct answer is 1 by 4, and other one will be 1 minus 1 by 4. Okay, such things I will teach you in the coming sessions. So you know that there will be a random experiment. You know what is a random experiment. So like the output will be unknown, right? So when we are doing a random experiment, that output is unknown, and that total number of outcome, whatever it is, that is what we call the sample space. Okay, listen, consider an example of tossing a die or throwing a die. So you know that there are 6 outcomes, right? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6. So these are the outcomes and these are the sample spaces, right? So see, throwing a die, we have the sample spaces. So like so I will say you have you are throwing a die and you have 6 outcomes. These are the sample spaces, and out of that, you like how many times 3 and 4 is occurring, so how many times 4 and 5 is occurring. Those are actually the events, and we call it the favorable outcomes. Okay, total outcome is the sample space, then we have the favorable outcomes. Okay, and then we have, then before that we have the total number of trial, right? So a coin is tossed, like you say coin is tossed 6 times, means 2 raised to 6 times is the number of tries. Sorry, 2 raised to 6 times is the number of sample space. Consider we have a coin, so we have 2 outputs. So it is tossed 6 times, so 6 is the number of trials and 2 raised to 6 is the number of sample space. Okay, so here we have the sample space is 1, 2, 3, 4, 5, 6, and the total number so the count n of s is 6, and a means, so our event is how many numbers are there which are more than 4, right? So set of 1 or more outcome of the random experiment, that is what we call the event. So that is actually the favorable output. So it is 5 and 6. So we know that the number is 2. The number of event is 2. So we understood that like the event, the number of the event will always be less than the sample space. So it cannot be 0 also. So we can say it can be equal to 0. If you're not taking anybody no output, means it can be equal to 0 also, but it will be always less than the total number of sample space. So 0 less than or equal to n of a less than or equal to n of s, right? So now I'm bringing you to probability. So first you understood what is a random experiment, what is a sample space, what is an event, everything you understood. And I spotted that with the example of tossing of a die, right? So 6 times we are tossing the die means 6 is the number of trials, and how many times the output we are getting, that is the like 6 raised to 6, or how much it is, that is the number, that is the sample space. So if a die is tossed once means the number of sample space we can get is 1, 2, 3, 4, 5, 6, right? So 0 less than or equal to n of a by n of s less than or equal to 1. So this is what you have been learning all your lower classes, and this is the probability. What is this? This is the number of favorable outcome by the total number of outcomes. So you have been by hearting what is meant by probability. The probability issue, probability is number of favorable outcomes by total number of outcomes. So how you get it? See, so you know, so this relation you got it from your previous example which I spotted for you. 0 less than or equal to n of a less than or equal to n of s. N of a is the total number of events, total number of favorable outcomes, that is our event, and total number of the sample is total number of the outputs. So n of a by n, we will bring it here, so it will become less than 1. That means we are dividing it by n of s, and that is the probability. So probability of a is n of a by n of s. So what you understood from here? Favorable is always a subset of total. That is, the probability of favorable outcome is always a subset of total number of outcome. That is, it is less than or equal. That's it. Okay, so in a mathematical way, as a closed interval, we can say that probability will be always a closed interval. That is, it will be ranging between 0 and 1. Probability cannot be more than 1. You have been learning this from your lower classes itself. So up to now, before starting the type of events, so what are all things you understood means? You should understood what is a random experiment. So any random experiment you have means that output cannot be determined. Like you cannot say this is the output. If you can say this is the output, means then the probability is 1. So you don't know like you cannot say you will be given 4 and out of that only 1 will be correct. So if only one answer is given and you have to find out that one, it means it's not a random experiment. You are getting the answer directly. So out of 4 only 1 is when, that's probability is 1 by 4. So such cases as a random experiment, then you know what is a sample space, you know what is a trial, how many times you are doing trial and all, it's coming in your normal distribution and all such things are coming. Now don't get confused. And then favorable outcome, then what is probability and the range of probability. That's it. Then coming to the type of events, you know that this is the most important portion considering your syllabus. You will get questions from types of events. So events are actually divided into equally likely events. So an equally likely event means events are said to be equally likely when the chances are same for occurrence of all the events. Okay, see the example. So chances are same for everybody. Example, we are tossing a die. So die means getting numbers from 1 to 6 are equally likely. So the chances of getting events are equally likely. You can get 1, you can get 2, you can get 3. Any number you can. You cannot say when you toss again you will get only 4. No, you cannot. You can get 1, 2, 3, 4, 5, 6. Any output you can get. So that's what we call a equally likely event. Okay. Now the another one, mutually exhaustive. You have mutually exhaustive and you have mutually exclusive. So mutually exhaustive means you have a 4 output, means all the 4 output together will make the sample space. Such cases we will say mutually exhaustive. That is, two or more events in a trial are exhaustive if one of them must necessarily occur. So, example means we are throwing a die, then all the 6 events are exhaustive because one should necessarily occur. Like one event is cannot happen, that because if you are throwing a die, you can get 1, you can get 2, you can get 3, you can get 4. So any event must necessarily occur. Any one answer you will definitely get. So that is why what we call mutually exhaustive. So probability of getting 1 plus probability of getting 2 plus all these will be that is that together will be the sample space. This is the case of a 4 output event. Okay, now the very important one is mutually exclusive event. So what is mutually exclusive event? In a mutually exclusive event means they will be separate entities. You see, they will be separate entities. That is, if occurrence of any of the event in a trial prevents the occurrence of the other event, then the events are mutually exclusive. So in that case, means they cannot occur together. Intersection is not there. That is, it's like if A and B are two mutually exclusive. So remember the word exclusive. If it is exclusive means A intersection B is equal to 0. That is, simultaneous occurrence or both happening at the same time is not happening. Okay, it's not happening. So whichever points I'm marking in red color, you also mark it in red color because it's important and you are going to get the gate questions. Okay. Okay, that means exclusive means it will be the same sample space. So like three occur, one mean like you get 3 means the other events cannot occur. Like you have already one output now. That's it. So any of the event in the trial prevents the occurrence of the other, then it is mutually exclusive. Now mutually independent, just opposite. That is, occurrence of one event does not affect the occurrence of the other. It does not depend. So we can say that intersection will be the probability of A into probability of B. In exclusive means intersection was 0. Independent means intersection is probability of occurrence of the first one into probability of occurrence of second. That is probability of A intersection B is probability of A into probability of B. That's it. Okay. Now dependent event. This is the most important. Dependent conditional probability. See the example. So 2 dice are thrown one by one. A is equal to 3 on the first dice, and our first event is probability of A is how many times we get 3 on the first dice, and the B is the total number should be 8. So you understood that the second dice should get the number 5. So it is a conditional probability. You have 3, the other one means you should get 8. So it is depending on the condition set by A. So happening of one event gives some information about the other event. That is depending. So in a mathematical way, we say it as conditional probability. Yes. So you can say it like conditional probability means probability of happening of A when B is already occurred. So already occurred means B will be the denominator. So the formula is like probability of A intersection B by probability of B. So probability of happening of A when B is already occurred, that is probability of A intersection B by probability of B. Okay, so some important points. When I ask you, you just say in your mind. Okay, so probability of A intersection B is equal to 0. What kind of event it is? Mutually exclusive. Okay, probability of A intersection B is equal to probability of A into probability of B. What it is? It is independent event. Okay, and now this formula you should remember. Probability of A union B is probability of A plus probability of B minus probability of A intersection B. Okay, and this also, this is not that important in terms of gate, but still you should have the key point with you. Okay, so probability of A union B union C is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. This formula you have studied in your lower classes also. But if it's an exclusive, keep in mind, mutually exclusive. What is important? Intersection is not here, not there. They cannot occur simultaneously. See, that means then it will probability of A plus probability of B plus probability of C. That's it. So we have finished studying types of events. Which are the types of events? Equally likely events, mutually exhaustive, mutually exclusive, exclusive, then dependent, independent. Sorry, first independent, then dependent. Dependent comes, brings you to conditional probability. Yes. Okay. Okay, now let's see one question based on what I have taught you till now. So, if P and Q are two random events, then which of the statement is true? My dear friends, look here. Which of the statement is true? So, the first statement is independence of P and Q. Don't check the answer which I have worked out for you. Just listen to what I'm saying. So, independence of P and Q implies that probability of P intersection Q is equal to 0. Okay, listen, what you will learn. Independent event means, no, independent event means intersection is not 0. Intersection is P of A into P of B. So, the first statement is wrong. Now we say probability of P intersection Q, they say, is greater than or equal to probability of P plus probability of Q. Is that true? Okay, rewind what you have learned. Okay, consider probability of A or B or probability of A intersection B. We say probability of A plus probability of B minus probability of, okay, we know the basic thing, like probability will be always ranging from 0 to 1. So we can write it like probability of A plus probability of B minus probability of A intersection B is greater than or equal to 1. Because A union B, it can be like that only, right? So when you bring it to the other side, probability of A plus probability of B, it will be greater than or equal to A intersection B. It cannot be less than. So this is wrong. Okay. So which is the other one? If P and Q are mutually exclusive, then they must be independent. Okay, think. Mutually exclusive and independent. Will that occur together? Mutually exclusive means, you see, they will be occurring like, that means occurrence of one will affect the occurrence of other. If one occur means the other will not occur. That means they are not independent. So this is not independent. That is same sample space is not independent. That's also wrong. Okay, now we are coming to the key point. Probability of P intersection Q is less than or equal to probability of P. Think, is it? Probability of P intersection B is less than or equal to probability of P. Yes, it's correct. That leads you to conditional probability. Bring this to the denominator. So probability of P intersection Q by probability of P is less than or equal to 1, because that is what we call conditional probability of A by B. Yeah, it's correct. But it cannot be, so this probability will never be less than 0. Probability cannot be less than 0. Yeah, that's why. Yeah, so this is correct. Now see the magic. I am going to make this a multiple select question. I added one more option for an exclusive event. Exclusive. For an exclusive event, probability of A union B is equal to probability of A plus probability of B. Yeah, it's correct. Exclusive means intersection will be 0. Yeah, correct. So this is also correct. This is also correct. That's how you frame multiple select question, MSQ. And remember, my students, you have this question without negative marking. Okay, so now we have the second question. A box contains 4 white balls and 3 red balls. Okay, you see we have 4 white balls and 3 red balls. In succession, 2 balls are randomly selected. So this is a key point, we'll see later. In succession, 2 balls are randomly selected and removed from the box. So 4 white balls are there and 3 red balls are there. So one by one you took one, then you took another one. It can be red, it can be both red, it can be both white, it can be one red, one both, anything. So remove from the board. So given that the first removed ball is white, the probability that the second removed ball is red is, so the first one was white, so we want to know how the second removed ball is red. So just remember, or you by heart it. Whenever in a question it is given, it is written like given that, given that, given that. That means it will be a question based on conditional probability. Okay. So see, you have the box, 4 white balls, 3 red balls. So he took one white ball, right? He took one white ball, right? He took one white ball, right? Okay. So one white ball is taken. So the probability of getting one white ball from total 7 balls is 4 by 7, right? And given that the first removed ball is white, comma, you have a comma there, comma, the probability that the second removed ball is red is, what is the probability that the second removed ball is red? So the question is not like find the probability that the first ball is white and second ball is red. The question is, if the first ball is white, then find the probability that second ball is red. Not that, they're not asking for together. So what is the second condition? You have 3 white balls and 3 red balls, but the total number is 6 because already 1 we took. So it will be 3 by 6, 1 by 2. Simple, 1 by 2 is the answer. Okay. So even if in succession, when we are taking it in succession, we take it like product rule. But since because of the way the question is framed, we got the condition probability here. One is there, then how much is the second? Not together. So we are not taking the product rule. Okay. Next question, very important. So this is important for electrical, electronics, mechanical, instrumentation, computer science, civil engineering, all branches. Even life science students, the biology, life science students, it's important for them. Okay. Consider a company, the next question. Consider a company that assembles computers. The probability of a faulty assembly of any computer is P. The company therefore subjects each computer to a testing process. This testing process gives the correct result for any computer with a probability of Q. What is the probability of a computer being declared faulty? Okay, what are given? The probability of faulty assembly of any computer is P. So the probability that one computer is fault is P. Therefore, the company therefore subjects each computer to a testing process. This testing process gives the correct result for any computer with a probability of Q. So, the probability of getting a faulty computer is P, and upon tested, the test result being correct is Q. So, what is the probability of the computer being declared faulty? So, you should consider both the cases. Okay, these are the questions. So consider every cases. Okay, you have one first condition, the computer is faulty with the probability P. So if it is not faulty, it means the probability will be 1 by 1 minus P. So next condition, we are checking it. So upon correction, it gives good result. That is, it gives the correct answer with the probability of Q. Not correct means it will be 1 minus Q. Okay. So here also same. Not if it is not faulty, then also we check it. Then the probability that it is giving correct answer is Q, not correct answer is 1 minus Q. So what is the question? What is the probability of computer being declared faulty? So we want to know when it is declared faulty, right? So the probability of faulty will be, which are the cases? Faulty cases means 1 minus P. So we have the probability. So when the computer is faulty, the probability is P. So you got it P, and upon checking also it gives correct answer means it is faulty. So that probability is P into Q. Okay, you have another condition. What is the another condition? It was not faulty. Yeah, it was not faulty. And upon checking also, but upon checking you got the incorrect answer. That means it is faulty. So 1 minus P into 1 minus Q, right? So here it is faulty. So you have two conditions here. First one, the computer was faulty, and upon testing also you got it correct. So it is faulty, P into Q. So another condition, the computer was not faulty, but upon testing it gives the wrong, it gives incorrect. That it is saying it is not faulty. That also is a probability. So total probability. So it will be 1 minus P into 1 minus Q. So the total probability of fault will be the first condition into plus second condition, PQ plus 1 minus P into 1 minus Q. Yeah, that's it. Okay, next question. A determinant is selected from the set of all determinants of order 2 with elements 0 and 1. Find the probability that the selected determinant is non-zero. Okay, so you consider a set of all, it's a second order matrix. So you know that this is A, B, C, D. So the sample space will be 2 raised to 4 because a determinant is selected from the set of all determinants of order 2. So here you can have 2 raised to 4 sets of elements, right? Find the probability that the selected determinant is non-zero. So determinant will be A into D minus B into C, and we need a condition when it is non-zero. We need a condition where it is non-zero. So, but it's better we go for the condition which is 0. A 2 by 2 matrix, when all the determinants will be 0, because we should get AD minus BC, we should get 0. So we will consider the cases 0, 0, 0, here determinant is 0, here determinant is 0, here determinant is 0, here determinant is 0. But along with this, we'll have three more conditions, which are that one can be here, one can be here, one can be here. If one is here, all others 0, one is here, all others 0, one is here, all others, that can also determine is 0. Then 1, 1, 1, 1, 1, 1, all these cases determinant is 0. So probability of getting the determinant 0 is 10 by 6. So what will be the probability of getting the determinant non-zero? Sorry, here it is 10 by 16. So the probability of getting the determinant non-zero is 6 by 16. Okay. So this is a homework question for you. This is the last question for this session. So this is a homework question for you. An examination consists of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3. This question is somewhat similar to the faulty computer question. Okay. The probability of failing in paper 1 is 0.3 and the probability of failing in paper 2 is 0.2. Given that, okay, given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. So what is the probability of the student failing in both the papers? So I want you to do this problem and comment your answer in the comment box. Okay? And let's see how many of you get it correct. So that's all for you from this first basic section. We will be having one more session where I will be making you do some more good problems regarding the basics. That is from the types of probability, types of events, then conditional probability, such areas. I will make you do some more good problems like probability of A by B is probability of A intersection B by probability of such areas. So, and the last problem, I expect everybody to do and give me the correct answer. I will give you the clue. It's basic conditional probability and it's a previous year gate question. Try to do it. Okay. I hope everybody might have understood this mathematics lecture. Normally I don't give mathematics lectures, but still I'm trying to do. So I hope this everybody find this video very much useful. So the students from third year and fourth year who haven't, these for students who hasn't done much preparations, but with the expectations your parents and teachers, you have made, like you are without preparing. If you are applying for an exam by paying 1,500 rupees, means you are doing it to be because somebody told you to do and you are doing. So it's better you give a try. I know you are all intelligent people, so it's better you do a try. So you just follow these lectures, you will get something. I want, so my wish is like anybody who follow my lecture get a pass mark, get qualified. So maximum what you need is 30 marks for getting qualified on an average. I'm saying all the branches. Some other branches will be very less also. So mathematics is the easiest and scoring subject. Okay, thank you.